Hello and welcome to another edition of Miles to Go. I'm Miles O'Brien. In this episode, we're going to take printing into the third dimension. 3D printing. It's been around for a while. It began as a clever tool for making prototype parts quickly. It evolved into a novelty, dare I say, a fad, a purchase for nerds to build something at home, make a custom iPhone case, a trinket, in some ambitious cases, even meals. Not good meals, I should tell you, having tried one. All I kept thinking about as I did was Soylent Green. But I digress. As the technology has progressed, it is now moving into a new dimension, if you will. 3D printers are now part of the manufacturing process. They're making specialty parts in products. Now, it's going to be a long time, if ever, before plastic injection molding is outmoded for certain things, like toothbrushes. But if you're making parts for a rocket, or an aircraft engine, or a rare vintage car, 3D printing is fast becoming a cost-effective and, in many ways, superior alternative. We have more on this story in our piece for the PBS NewsHour. Go to the web, check that out. One of the conversations I had in the course of producing that piece was particularly interesting. It happened with a man by the name of John Hart. He is an associate professor of mechanical engineering and director of the Laboratory for Manufacturing Productivity at MIT. And he is one of the people helping lead the way into a 3D printed world. Okay, so I want to get a little bit of the history of 3D printing, but I also want to get a little bit of how you came to it. Those might be slightly intertwined, right? So why don't we start off with how you came to the world of 3D printing and how you, I'm sure there's a long story there. We need the medium story or
Sure.
less, but give us an idea.
Sure. So I've worked in materials and manufacturing since I was an undergraduate. And bottom line, when I came to MIT as a faculty member 4.5 years ago, I was interested in new things. And I thought that 3D printing was an exciting area where we could make a lot of impact in the future.
So let's give me a quick bit of history on 3D printing, how this all evolved.
20, 30 years ago, even longer, there were pioneers who thought that there were alternative ways we could make objects. Contrasting, machining, casting, molding. Could we build objects layer by layer from the bottom up? And the component technologies were all there. Digital files, computer-controlled machines, design software, but they were in such early stages. They invented a series of technologies, some of the same technologies we use today. And for those 20 or 30 years, or most of that, we were using them for advanced prototyping, making single parts with cool designs, but we were constrained by the fact that we could not take those prototypes for 3D printing and translate them to mass production.
These were plastic parts that would just help you visualize how pieces might come together, that kind of thing, right?
Yeah, plastic parts for fit and function testing, some metal parts. There was metal printing back in the day. It was really rough and ugly, but it was there. And, multicolor objects. One of the first users of 3D printing was actually Hollywood for props and miniatures for special effects before we did a lot of, CG animation and so on.
So by the time you came to it 2 or 3 years ago, you said, right?
Yeah.
Things had changed pretty dramatically from those early days. Tell us a little bit about what happened from those early ideas to that period of time.
So it's a few things. I think it's the continuous evolution of the technology and the fact that the components, if you break it down, the machines, the materials, and the software kind of came together in a critical way. And with that, there's also confidence in demonstrated value of 3D printing in the marketplace. And that's getting more people interested, willing to invest their time, their money, take risks, and that is building upon itself.
So, it's easy to go to computer analogies. You talked about the era that would have been the mainframe era.
Yeah.
Are we in the kind of the early PC era? Are we before the IBM PC, or where are we right now in the progression?
Hard to make a specific analogy. I'm certain we're in the early stages. Right? I think the things that we do with additive manufacturing, in the end, say 10, 20, 30, 50 years from now, are in some part beyond our imagination. We don't know exactly how we'll deploy the technologies, how the role of the engineer, the designer is going to change, what the factory is going to look like. But we'll keep building upon it and get there.
Is there any doubt in your mind that this is an overused word, revolutionary, but is it revolutionary, you think?
I think it's revolutionary in the following way. First, additive manufacturing is one piece of the factory of the future that includes 3D printers, more robotics, more computation, data handling, etc. So it is in a way a cornerstone of the factory of the future. In addition, there are industries and applications where it enables a total rethink. Right? There are places where you'll still only be prototyping using 3D printing, and there are places where maybe you'll be printing spare parts down near the end of life of the product. But there are also cases, and these will grow versus time, where the fact that you can not only prototype with 3D printing but also produce with it is a total rethink of the product life cycle. And I mean you can design parts and products with new capabilities, funny geometries that have enhanced performance that you couldn't think of before. You can also think of your factory and your supply chain being structured a different way. You don't have to buy fixed equipment and tooling dedicated to one part or one product. You don't set up arrangements with your suppliers in the same way because you can access more flexible production. You can produce on demand. And those are the ways in which will completely change how we design, develop, deliver, and service products.
I think those who are familiar with 3D printing would say today this is for limited to custom type things, trinkets, oddities, but it's not ready for manufacturing prime time. Is that changing?
That's changing. We're not quite there yet. You're correct, right? Still, by and large, 3D printing is slow. It's expensive, right? There's few things that you can 3D print and then use right away. You often have to do post-processing and finishing and painting, et cetera. But we're getting there. We're getting there in terms of the core performance of the 3D printing processes, right? Low-cost materials, high-speed machines, better quality. And we're also getting there in terms of integration. We understand how to use 3D printing in combination with other processes that are useful to make products.
So, all right, for somebody who is uninitiated, give us the basics on what it is and what the advantages are.
3D printing is the process of building up an object layer by layer from digital data. That can be applied to plastics, metals, materials we haven't yet invented. What makes it so amazing from a design point of view is it can create geometries that we couldn't create before. There's a lot of constraints with machining, molding, casting, other processes that you don't have to pay attention to. In addition, you can derive performance from those complex designs, and performance leads to value and function. From a research point of view, we're really excited because I think it's the ultimate combination of the machine, the material, and the software. And you can locally control the processing of the material in a unique way. So we're not quite there yet in the application space, but you can think of not only making a part that has a complex shape and geometry designed for function, but you can think of even designing the properties of that part locally to enable even greater performance. So there's a long future not only in the commercial marketplace, but also in research, and in the ability to translate that research to the marketplace, because we can base it on digital technology, automation, software, simulation.
And we saw a brief glimpse of if you throw a little machine learning, artificial intelligence in there as the designer, you can design in ways that an engineer wouldn't even possibly conceive of, right?
Yeah, I think the role and the job of the designer and the engineer is going to change. Not to say by any stretch that the creative process is going to go away, but we're going to learn to work with computation and algorithmic assistance in new ways. A lot of people are thinking about combining machine learning, artificial intelligence with 3D printing or with advanced manufacturing broadly. There are a lot of possibilities there. Value depends on the specific use case.
So if you're looking at this relatively optimistically, maybe inevitably, it seems like a real fundamental shift in the way manufacturing exists. If you're, instead of shipping products and parts, raw materials to places to make parts to make products,
Yeah.
it totally changes the supply chain and everything else. Is that accurate?
Yeah, right on. In some places we'll get there. It'll be a long time, but that is to some extent the future, right? It's not that the existing processes are going to go away, and for good reason, because they're awesome and fast and inexpensive. And if you look at the fundamental limits of those processes, cost and rate and energy consumption, I can't imagine that 3D printing is going to beat machining or injection molding if you want to make, 1 million parts or 200 million parts. But there are cases where 3D printing is going to win, and also the fact that 3D printing introduces additional dimensions of value, like performance, strength at low weight, or time to market. There are different arguments and comparisons to be made.
So it's not as simple as that, the cost per unit. There are other
Right.
factors in play here. But I mean, it's hard to imagine, doing like I use these little flossing things, little plastic flossing things. That's always going to be injection mold, right? Things like that, high volume, inexpensive kind of things. Or will we one day 3D print that?
For a long time, we'll be using injection molding for something like that. That's my guess, but maybe there are ways that it could be better.
So what's the number right now? Is there an arbitrary number where you can say, well, once you get to 150,000 units, it's injection molding? Or do we have a number?
It all depends.
Yeah.
Some rough numbers I can say, look at a plastic part, a housing for, say, something like a cell phone. And injection molding would beat 3D printing at quantity of a few hundred to a few thousand. So if I'm launching a commercial product, no way I think about 3D printing. But if I want a prototype, obviously, if I want to test the market, that's really interesting because I can get 1,000 parts made quickly and cheaply, and maybe it's a few times 1,000 with a few different designs for my customers to get their feedback. For some of the high-performance metal printing technologies about to hit the marketplace are talking about tens of thousands or more, competing with casting, die casting, used in the automotive industry for suspension components, for engine components. Not the whole engine, but key high-performance parts that can really make a difference.
Man, it occurs to me that the guys who have all those junkyards with the cars waiting for somebody who needs a carburetor for a '57 Chevy, they're out of business, aren't they?
Not for a while. But you are seeing people 3D print replacement parts for high-end cars, old classic cars. There's a business there. There's a lot of small businesses, and the effect of this technology on the small and medium enterprise cannot be understated. There's a real need for education and enablement there.
So, but in your view, it would be inevitable that it's going to move into a more mass market type run, bigger numbers.
Without a doubt, and that's going to happen very soon.
What's holding it back right now? What are the issues that are obstacles to get you there?
So there's always obstacles when you implement a new manufacturing process, right? Cost and speed and quality. In 3D printing, two important ones are one, qualifying parts, knowing that the 3D printed part you get is good enough for your application. We're seeing the aerospace industry, which is one of the leaders, investing a lot of money and time, start to develop ways to qualify parts. GE, for example, and others. Another barrier, frankly, is education, learning. I think knowledge is one of the most important roadblocks to doing more with it. If we froze the technology today, all the startups stopped, all the companies stopped trying to innovate, and we just stopped and learned and adopted, we could do a lot more. We could go on and grow for many, many years.
Well, explain that a little more. What do you mean if you froze it? If you froze what technology?
I mean, if we just said we stopped trying to do better. We just said the performance of the technology stays the same, and we focus on learning and understanding where the technology is now. We'll continue to grow the size of the market, the number of applications.
Okay, so there's a lot of just untapped demand, even at the present levels of technology.
A lot of untapped demand by understanding the true capabilities, what you can use it for, what you shouldn't use it for, and why. Even simple things like front end of the product development cycle. One of my favorite examples is a major food company 3D printing plastic potato chips, right? Like to give to their customers to say, do you like the feel of this potato chip? You don't eat it, but you feel it. And they say that shrunk their development cycle. Right?
You mean
simple things.
Faster than frying a potato?
Well, faster than making the tools and creating the ridges and so on. Yeah.
All right. So up until this point, it's slow. It's kind of kludgy. It's like early computer days, to go back to that analogy.
Yeah.
But I mean, what's happening to speed it up?
Machines that can fuse materials together faster, creative ideas that let us overcome barriers to speed, better materials, some materials that can be 3D printed faster with higher quality, software and control algorithms, right? Just like if you looked at the evolution of industrial robots versus time, robots have gotten smaller and lighter and faster. That's both the hardware and the software. Same thing with 3D printers. The faster I can move the nozzle or move the inkjet head or scan the laser, the faster I can print, and the better the economics of the process will be.
So is there a Moore's law for 3D printing?
Great question. You're not the first one to ask that. I don't think there's a similar one, but it's interesting, in my opinion, to think of how the component technologies will work together to accelerate the adoption, the rate, decrease the cost.
Okay, so we were at Desktop Metal, and you were a co-founder, is that correct?
Yeah, I'm a member of the founding team.
Okay, so help us, we struggled a little bit with Rick explaining the difference there, what makes it the secret sauce without giving away the secrets, right?
Sure.
What is it about it that makes it conceivable for bigger runs? What do you do differently?
So if we're talking about the production process, it's the speed and economics of the process. So Desktop Metal's production system is a technology with innovations upon the original binder jetting 3D printing process that lets the machine build parts very, very quickly. An inkjet process is used to deposit what's called a binder on metal powder, and then those parts are taken out and they're sintered, basically turned from low density parts to high density parts in a furnace.
So walk us through that. I'm trying to The bottom line is you're not cooking it as you go. You save the cooking for later, and
Exactly.
that saves time. If you could give us some layperson's way of understanding what's different there. The binder is part of it,
Yeah.
and you put it in the oven afterwards, and that saves time. But I'm doing it
Yeah.
poorly.
Sure. So a way to think of speed in 3D printing is how many points at which you're building the part, right? So if I have a single nozzle, like a desktop plastic printer, I only have one point at which I'm building. The rate is limited by the speed I can move the nozzle. If I can multiply that by 10 or 100 or 1,000, I can go much faster. So in the single pass jetting process, you have a bar of inkjet print heads that deposit a glue, a binder, that define the shape of the part. And all of those print heads, many, many thousands of them, move at the same time. And therefore, I can multiply the rate by a huge number. And then I move one layer, I spread the powder, I do another layer, I spread it again, and I have a big box of parts encased in powder that I can then remove and put into a furnace to sinter.
So, and the reason that the binder kind of comes with it is to just facilitate all those nozzles doing its job. Is that right?
So the nozzles deposit the binder to glue the material together. Think of what's called a voxel, which is a three-dimensional pixel of a part. So every time a droplet of binder hits the powder, it's fusing a voxel of powder together. And each of those voxels adds up to form a little bit of each part.
Okay, and so that's really a big shortcut, because up until this point, if you could describe the previous way of doing it.
Yeah, so the prominent method in industry now for metal 3D printing is scanning one or more lasers. It's a more difficult process to control in some ways because you have to scan a laser across the powder and form a melt pool. Very high temperature, and you can only incorporate a few lasers in the machine. So you can't go this way of having thousands of inkjet droplets coming down at the same time.
I see. Too many lasers.
The laser technology doesn't work the same way that inkjet technology
Got it.
works in terms of scalability.
All right, so this is, and even with the extra time of putting it in the oven to shrink it down, it's still faster, right?
It's still faster, right? You think of you buy a printer that has a fast speed, and then you could have multiple furnaces that could work at the same time.
So is this a big breakthrough, you think?
I think it's a big breakthrough. I think it's one of many breakthroughs across the industry. Metal printing, plastic printing, composite printing, and there are many more players in the industry with time. Small companies, big companies, many technologies. I think all the technologies are going to survive. The ones that thrive are those who take the technology to the best mode in the marketplace. Understand what it's really useful for, if you get what I mean.
So you got a lot of competitors.
Yeah.
Yeah. How do you guys feel about your business and where you are right now?
It's still the early stages, but we're excited about what we've done so far, and it's about getting real parts into customers' hands. I think that's the ultimate proof when they want to make more and when they want to both prototype and produce using 3D printing.
And you have customers lined up waiting, as I understand it. Yeah.
There's quite a portfolio of companies that are interested in what we're doing, and our job is to prove it.
Has anybody built a printer quite like that big one we saw today?
The big industrial printer? I think it's the first of its kind. Probably to be the fastest metal 3D printer in the world, at least relative to the detail of parts it can create.
Right now, what are the ideas? The aviation remains the kind of thing that would require, is the right number of units, right? Is that what it is that makes aviation interested, or what is it?
So aviation's really interested in 3D printing because there's a high premium on part performance. And with 3D printing, you can, for example, reduce weight while maintaining strength. You can make a part like this lattice structure, which you could not make using existing technology. And therefore, even though printing is still relatively expensive and slow, and there's not only the cost of printing, but the cost of qualification, it's worth the investment. And other industries without quite the cost and value premium are getting interested. We're seeing everyone really take action in particular ways, and as the technology matures, you're going to see it climb down the cost volume curve, go from aerospace into automotive, start to make more tooling. The medical industry for orthopedic metallic implants is making a lot of great progress. Not even yet to customization. A dream in a way is having individually customized medical implants, but just taking advantage of the capabilities of 3D printing to do something even as direct as decorating the surface of a hip implant with a fine lattice structure that is shown to increase the rate at which the implant grows into the bone. So measured clinical benefits that justify the investment. That's what it's all about. Like aerospace, space exploration, or like the aircraft industry, space exploration. In a way, it also lets more new companies enter the industry because you don't have to go the traditional route, right, of sourcing and contracting a rocket engine. A lot is involved in something like that, but if you can 3D print big parts of it, you can consolidate the supply chain, you can build your rocket at lower cost, and you can also increase performance because you can make these complex geometries for combustion and fuel storage.
So have you thought much about how, what the world looks like in 50 years with all this, as far as, if you're in the shipping business, or for that matter, you're charging tariffs on goods. There's a million things that get affected by this, how the workforce is structured, et cetera.
Sure.
All those things.
A lot of things. For me, it's too early to tell. I think it's really beyond our imagination, but we'll see in specific important industries, all of those factors come into play. From how the designer, the engineer goes about their work, to what the factory looks like, to how business agreements are structured, to where factories are placed, to what production workers do on a daily basis. It's all going to happen. And I like to think the goal is to get ahead about the understanding and the vision and help make it happen.
What are the products, we talked about products that are likely to be 3D printed or already are. What are the products that are least likely to be in the 3D print realm as we look toward the future?
Yeah, so least likely, inexpensive parts that are made at very, very high volumes. Right? Bottle caps, Lego bricks, things like that. And a lot of, if you say metal parts that are made in really incredible quantities and or at very, very large scales, large dimensions.
It does allow engineers to design in an entirely different way. Tell us a little bit about that. How it, it allows you to color outside the lines in a big way, doesn't it?
Yeah, so the fundamental difference is instead of starting with a fixed design, even a sketch in the computer, and then changing its design to take advantage of 3D printing. Here you just start with the constraints. I need the part to go from here to here, and you let the computer form the part for you. And there's an algorithm behind the scenes that adjusts how to grow it, how to remove material to meet a desired function. For example, minimize its weight but maintain a certain strength.
So it creates things that look very much in the natural world.
Yeah.
Did that surprise the likes of you when you started realizing what artificial intelligence tells us is the best way to do things?
Yeah, in some ways yes, in some ways no, right? It's known that many natural structures, such as bones, are optimized to some extent to perform their function. And that's happened over a large number of years. And each generation is some form of an iteration. And if you can have a large number of generations in a computer in a short amount of time, maybe it's not surprising that things look natural, things look biomimetic.
So, in science fiction, the humans are in these sleek, minimal spacecraft, with perfect lines and everything. I think 2001 or Aliens. And it's the aliens that look like the thing you're producing. Do we have it backwards?
I don't know. The more I think about all of this stuff together, the more I think that we're approaching an era of science fiction. But maybe 100 years ago, people would think that our life today is total science fiction.
There aren't many categories in general where you can talk in the same sentence about things being very customizable and also very scalable.
Yeah.
You're kind of doing both.
It's often said that complexity or customization in 3D printing is free. I mean, to large part that's true. In some ways it's more than free. It's less expensive to make a part that's complex in its geometry than it is simple in its geometry, because you use less material and less time if you 3D print it. In terms of customization, right, many examples from the medical field. Orthodontic aligners, Align Technology has been producing 20 million or so of these parts for many years. The whole hearing aid industry flipped over to 3D printing rather than manual casting in a matter of, I believe, 500 days. Incredible transformation.
Wow, I didn't know
because
that.
It was so cost and time effective. The old way just didn't make sense when you look at it. And there's so many things of manufacturing that just so inefficient. Right? Manufacturing is awesome. So many things are made in factories. Factories are fast and impressive. But when you look at the process of building that factory, when you look at the time involved in going from the design to production, you say, well, that is just inefficient. And we're going to smash that up into a much smaller, more efficient enterprise. That's perhaps the biggest implication.
You don't want to be in the tool and die business, right? You got to sell that short, right?
I mean, it's a great opportunity for them because in the end, producing things will always involve the human element. So if you're a small and medium enterprise and machine shop, learn about 3D printing. If you can get access to a 3D printer, bring one into your operations and 3D print parts and then machine them and create, new things for your customers. It's a great opportunity. Those who don't catch up might fall behind. Same thing for craftspeople. I think our artisan industries are in some ways thriving because there's new modes of distribution, right? And if I extend not only 3D printing but digital production, right? Garments and textiles and artwork and jewelry, more access to production capacity without big investment. So I think it leaves premium on creativity with digital influence, and provides a more distributed in a way democratic access to manufacturing. That's really important.
John Hart with MIT, thank you very much for your time. And thank you for listening. This has been Miles to Go, and I'm Miles O'Brien.